Right. I do not know why that is what's up on the screen. Hold on. It's like it just decided to pull whatever it wanted to up on the screen. There we go. That's better. Let's go through the bell work. So first thing I want to know is, do we know from just the information that they gave us right there, can you tell me what the value for R is? No. It's not necessarily drawn to scale. So what is this 384 pi that they gave us right here? Area. Area of what in the picture? Sorry, that zoomed in. This 384 pi is the area of what in this picture? Yep, everything up here on this picture that is shaded green, that is what is 384 pi. So this is the green shaded space, the grass. How do you think they calculated that? What would you need to do to calculate the green shaded space and come up with 384 pi? 3.14 or pi times the radius and squared. What do you notice about this green shaded space though? Is the green shaded space like a full circle? Where's the grass? Because 384 is the part that's covered with grass. Is there grass covering the entire circle there? It's more like a donut, right? It's got this hole in the middle where I'm assuming they have like concrete or something, since there's a statue in the middle of it. So they probably have concrete around where the statue is, and then there's this circle space here with grass on it. I don't know how to calculate the area of a donut. I know how to calculate the area of a circle. What would you need to do then if you were going to calculate the area of this donut shape? What could you do if all you know is how to calculate the area of a circle to find the area of that donut shape? What has happened to make a donut? We started with a circle, right? And then you do what? What happened right in the middle? They got cut off. They took it away, right? How do we take things away in here? We subtract them. Could I potentially find the area of the whole big circle as if it was filled in? Could I find the area of the space that's not filled in? So I could find the area of the big circle as if it was all filled in. I could find the area of the little circle, that part that's not filled in. Would we add it? Has it been added to this picture, or is it something that was taken away? It was taken away. So what operation would I use to take away? Subtraction. All right, so I'm going to write down what we just wrote, or what we just said out loud. That the area of the green donut would be equal to the area of the big circle minus the area of the small circle. How do you find the area for a circle? Nope, not for a circle. Actually, he's not horribly far off. Area for a rectangle is length times width. What's the length of a circle? Close. The distance from the center to the edge we describe as what? Oh. Yes. Pi times the radius squared. We're squaring the radius because this distance, that's like my length, is the same as this distance, which would be like my width. So that's why we have that r squared piece, and then we multiply it by pi. Area of a circle, pi r squared. What's the radius of the big circle? Where is this big circle that I'm talking about? It's the green one, and it would include everything in there. This is my big circle right here. So I want the radius of that. You measure the radius starting where and then going to the edge. Where do we start when we're talking about a radius? It goes from what part of the circle to the edge? It goes from the center to the edge. So for the big circle, I need to know what is this length right here. Do we know any part of that? The green part is 12. So I know this part right here is 12. Do we know this part? Have they called it anything? Look again. They've called it R. I need to take from here to here, the 12, together with from here to here, which is R. When I put things together like that, what operation are we doing? Adding. So this whole distance from edge to center is 12 plus whatever R is. I don't know how big R is, but if I knew how big R was, I would just add 12 to it, and that would give me that whole big long distance. So when I'm finding the area of the big circle, I have pi times 12 plus r squared minus the area of the small circle. How do we find area of a circle again? Pi r squared. What's the radius of the small inside circle? We don't know that. They didn't tell us that. What are they calling that distance? R, from the center to the edge of this donut. They're calling that R. So this would just be pi times r squared. Do I know the area of the big green donut? $384 pi, yes. If we can solve this, then we can find R. What operations are they asking me to perform on the right-hand side over here? On the right-hand side of the equal sign, what operations do I need to perform to do this? I need to perform multiplication because we're going to need to square that binomial. And then we're going to need to do what? Subtract. Let's square that binomial first. What does it mean to square something? Times it by itself. So I need to do 12 plus r times another 12 plus r. How many things am I going to need to distribute here? How many distributions do I need to do? 4. Every piece of my first binomial needs to get distributed to every piece of my second binomial. So I have to take the 12 and multiply it to both pieces here. What's 12 times 12? 144. Come on. $144. What is 12 times r? 12r plus 12r. What else do I need to distribute? R from right here has to be distributed. What is r times 12? 12r. What is r times r? R squared. Do I have any like terms to combine here? Which ones? 12 r's are going to combine. All right, so let's come back over here. I have pi that's going to get multiplied to this. I have 144 plus, what happens when I combine those r's together? I have 12r and another 12r, 24r plus r squared. Remember, when we're adding and subtracting, the power, the exponent never changes. Only the coefficient can change. And then I have minus 11r squared. And all of that is equal to 384 pi. What do I need to do over here before I'm allowed to subtract that 11r squared? Sorry, that's pi r squared, not 11. My apologies. What do I need to do right here yet before I can subtract pi r squared? We multiply everything by pi, yes. So I'm going to take pi and distribute it to each piece here. So I have 144 pi plus 24r pi plus pi r squared. I bring down my minus pi r squared. On the other side, that was equal to 384 pi. Do I have any like terms that I can combine here? Do we have anything that has the same variable that has the same exponent? Pi r squareds. Here I have a plus pi r squared, and then I have a minus pi r squared. What's going to happen there? It's going to cancel out. I have no more pi r squareds. What is it that they asked us to find here? The radius. Which piece down here is representing the radius? What letter do we have that represents the radius? R. So I want to try to get the R all by itself. How many terms are over here? I have 2 terms left. How many of those 2 terms have R in them? 1, just that one. So let's get rid of this one. 144 pi, is that a positive or a negative 144 pi? Positive. How can I make it cancel? Subtract it. So I'm going to minus 144 pi from both sides. Cancels out over there. What is 384 minus 144? 240. So I have 240 pi equals 24 r pi. I want just the r, so I need to get rid of this 24 and I need to get rid of the pi. What operation is currently connecting the 24 and the r together? Multiplication. So how will I make it cancel? How do I get rid of it? Divide it. And if you do it to one side, do it to the other. So I'm going to divide both sides by 24. Is there anything else over here with the r? The pi. What operation is connecting the r and the pi together? Multiplication. So what would I use to make it cancel? Division. So I'm going to divide both sides by pi also. So pi is going to cancel. So I have just r left on the right-hand side. What's going to happen on the left-hand side? We're dividing. Will anything cancel? The pi's. So all I need to put into my calculator is 240 divided by 24. 10. That is my measurement for r. R equals 10. Did we have units with that? Did they give us units anywhere? Feet. Right up here. So this is 10 feet. If this space right here is 10 feet, what's the radius from the statue all the way out to the edge? 22. Tell me how you got that. Yep, we had that little bit that they gave us that was 12. And then we found that the inside part was 10. So we add those two together and we get 22 feet. Awesome. All right, everybody should have a worksheet that says additional practice with long and synthetic division. Should have 2 problems on the front. Looks like this. If you don't have one, ask the person on the aisle to pass them over. All right. We're going to do the first problem together, and then you guys are going to have the opportunity for candy. Huh? All right. On this first problem, we can practice this using either long or synthetic division. Long division is what we did 2 days ago, where I draw out my big long division sign. I put the long polynomial underneath it. I put the little one on the outside. Yesterday, we learned how to do synthetic division. That's where we worked with just the numbers. We just grabbed the coefficients. Real quick show of hands. If you want to do what we did yesterday to practice again, raise your hand for me if you want to practice with synthetic division. It's where we have like the equal sign with the little leg on it. All right, if you want to practice this using long division, raise your hand for me. All right, synthetic division wins. So synthetic division, I have this little box over here. How do I know what to put in the little box? So we're going to come over here. What do I do with this to figure out the number that goes in the little box? Set it equal to 0. X minus 2, set it equal to 0. What do I need to do here to get the x all by itself? Add 2 on both sides. So x is what? X is positive 2. This is what I put inside that little box. So I put a positive 2 here. Where do I get the numbers for over here? Big polynomial, and I just want numbers, just coefficients. What's my leading coefficient? 1. In front of the x cubed is a 1. Remember, this is my x cubed right here. So we started off with degree 3, x cubed. Drop a power. What's the coefficient on x squared? -4. What's the coefficient on just the x? -11. And then what's my constant? 30. All right, so I've got all the coefficients, all the numbers. I leave a little bit of space. I draw an equal sign or an equals bar, and I give it a little leg. The little leg is always just sectioning off that last number, because what will end up right here? That's where my remainder will be. All right, how do I start this process then? Bring the first number straight down. Whatever it is, you bring it down. So I have a 1 here now. What do I do after that? Multiply the 2 and the 1 together. 2 times 1 is 2. I write that down here and I add. What do I get when I add those two? -2. All right, what do I do next? Multiply here, and I write the answer down here. 2 times -2? -4. Add it to the number up above. What do I get when I add those? -15. Next. Yep, multiply those together. You're absolutely right. We get -30. Add it to the number up above. What happens when I add those two together? 0 for my remainder. Okay, so what does that 1 and -2 and -15 mean? Those are the coefficients for my answer. The 1 is a coefficient on what? X cubed again? X squared. It drops a degree. So this is my x squared now. So I have 1x squared minus 2 what? Minus 2x minus 15. This guy back here is my constant. All right, so this problem's a little bit different than yesterday. What did they ask me for over here in this box? The roots. We found one of them. When we solved there for x, we found one of our roots. The way we find the other two roots is that we factor this. We practiced factoring. We learned how to factor in the last module. We're going to practice it again today because it's really important for our next module. So this gives us a chance to remind ourselves of that skill. If I'm going to factor this, what do I need to draw on my page? A box. I'm going to draw an area model, a box. What goes here? The x squared, my a term, absolutely correct. So a goes here, that's x squared. What goes here? -15, my c term. How do I decide what goes in these spots? This is where I make the x. We multiply a and c together, just the coefficients. What's the coefficient on a? 1. C was -15, so I need two numbers that multiply together to give me -15. But when I add those same two numbers together, I get what? -2. You said -5 and positive what? +3, absolutely correct. All right, so I have -5 and +3. What do I have to do when I put them inside the box? They need x's with them because they have to add together to give me negative 2x. What do x squared and negative 5x have in common? What can I take out of both of them? I can take an x out. What about 3x and negative 15? What can I take out of both of those? 3. Positive or negative 3? Positive 3. There's a factor. What do x squared and 3x have in common? What can I take out of both? X. And what about negative 5x and negative 15? Negative 5. Do you remember up there at the very beginning, you told me to take x minus 2 and set it equal to 0? What do you think I should do with these two factors? Same thing. I'm going to take x plus 3 and set it equal to 0. I'm going to take x minus 5 and set it equal to 0. And we're going to solve both of these. Right here, how do I get the x all by itself? Minus 3 from both sides. And so I get x is what? Negative 3. There's another one of my roots. How do I solve the other one? Add 5 to both sides. And so x is positive 5. That's my third root. I want you guys to take about 5 minutes and repeat this process with number 2. This is where you have the opportunity to earn candy. If you work on this one, even if you don't get it finished or get it right, but you have worked on it, you will earn a piece of candy. Yep, I'm going to leave this one up while you guys work on number 2. So all that negative sign is telling you is that this polynomial right here is what you are dividing by. It would go like on the bottom of the fraction. So you don't have to do anything with it at all. Oh, yeah. Yes, sir. This one is a divide. That's what that little negative 1 means. Here, this is the third question I've had about it. Guys, I'll bring this right back up on the screen, but before you get in too deep here, I do want to remind you, what does this little negative 1 as an exponent tell us about this? Means it belongs on the bottom of a fraction. So if I was doing long division, this is the part that would go outside my long division sign. So if I'm doing synthetic division, this is what I would want to use to figure out the number that goes in that little box. You don't have to do anything with that exponent. It is just up there to tell you the location that this belongs on the bottom of a fraction. You don't need to do any operations with it. All right. You had a question for me, sir? No, you just wanted me to leave that up. Sorry. No, it was that. Oh, that little negative 1 piece. Okay. Yep. And I want you guys to work through number 2. Do it just the same way we did number 1 here. So far, so good. Yeah. Yes, absolutely correct. Yes, you did. That is not correct, though. This is, if you distribute this, does 25 times 20, negative 25 give you 25?
Incorrect.
Okay, shut up.
But you had the right idea. You absolutely had the right idea. I want you to repeat the pattern that we did up here
Yes.
with this. So what number belongs out in that little box like that? How are you going to find that number? Where did we get that from? Look on your paper, you have it. Where did we get this number from?
This.
From this. How did I get that?
From this.
We took that and we set it equal to 0.
Yeah.
So what looks similar to that down here?
This.
Yes.
Question.
Yes.
So,
You did it absolutely correctly.
Mhm. So to get, I multiply that by that, but since it's just gonna be 25. what do
So
I-
you don't write it on the bottom. You write it right here. No, you had a minus 25 right here.
Oh,
I think you got your stuff out of order.
okay.
You brought that
Oh,
down.
it's gonna be 0, so there's not a remainder. Okay,
Yes.
thank you.
You're welcome. That's looking fantastic. You're absolutely correct. That is not correct, though. What multiplies to this, but adds to this?
That'll be like.
Yes, there you go. Seeing lots of really good work as I'm walking around. You don't have to. If you got a 0 there, you can just leave that piece out. Because you're right, those would be like terms and then you could combine them. What you have is correct. That is correct. That's not an x though. That's x squared. Where's your x go? No. This was x cubed. So comes x squared. This was x squared. So there. This was x. So that will be your, that's your constant. Yes.
So let's see.
No. You wrote 1. That's not 1.
Oh, 0.
What is 0 times x? Just 0.
You can't really subtract.
Do you have any like terms here?
Yes, these
Those two. Combine those two together. Yep. Now factor that. Lots of really, really good work. All right. Talk to me first. What is the number that's going to go in the little box over here all by itself? 1. How did you get that? Yep. X minus 1 equals 0. And then we solve that for x. So I put a 1 right here. Where else do I put that 1? That's one of my roots. All right, what are the coefficients that I want to write down after this 1 in a box? What numbers do I write down next? Guys, help me out. What are the coefficients that I write down? I've got the 1 in a box. What do I write down next? 1, -1, -25, +25. Then I get my equal sign in here with the little leg. Remember, this is my x cubed. This is my x squared. This is my x, and this last one is my constant. What's the first thing I do now? Bring the 1 down. And then what do I do? 1 times 1, which gives me 1, and I add it to the number up above. What happens when I add those? I get a 0. They canceled out. That's okay. Then I multiply these two together, and I get 0. Add it to the number up above. So what do I drop down? Negative 25. What else? Multiply those two together. Negative 25. What happens when I add it to the number up above? I get a 0 remainder. So what is my polynomial then? X squared minus 25. Drops a degree, so it's 1x squared, 0 x's, and this is my constant. If you have a 0 in any of those spots, you don't need to write it down. Oh, it's not wrong if you write it down, no. If I'm going to find my remaining 2 roots, what do I need to do with this? I need to factor it, yes. I only see 2 terms, though. I don't see a trinomial. Do I have A and B, or do I have A and C, or do I have B and C? A and C. So what is B? 0. That's what we had right up in there in the middle, right? So if I'm thinking about my area model, this is one that we can actually do without an area model. But if I think about my area model, I have x squared here. I have negative 25 here. I need this to multiply to be negative 25, but add to what? Add to 0. Well, what numbers do you know of that will multiply to negative 25, but add to 0? Negative 5 and positive 5. What do x squared and negative 5x have in common? X. What about 5x and negative 25? 5. Positive or negative 5? Positive. X squared and 5x? X. Negative 5x and negative 25? Negative 25. Sorry, not negative 25, negative 5. What do I do with those to find my remaining 2 roots? Set them equal to 0. X minus 5 equals 0. X plus 5 equals 0. So what are my 2 other roots? 5 and negative 5. X equals 5. X equals negative 5. All right, I'm going to come around with my bag o' candy. If you worked on this problem, you will get candy. I need to see it. If you want a second piece, do number 3 on the back, and I'll give you a second piece. Absolutely same exact process for number 3.
There's both. There's both.
Shouldn't get a remainder. I'll be right back there, sir. Let's see.
It's supposed to be.
-3, -1. What's negative times negative? There you go.
Just bring it on the 2.
I just bring down 2 or it'd be 3.
Hmm?
I just bring down the 2, right?
Why don't you listen to me? I know what I'm doing. You're the one who told me.
You don't need a plus sign in between it though. Because you're not adding those coefficients. Are you gonna work on the other one with us, sir?
This one?
Number 3.
Oh, I'm supposed to work on it?
Yes, you are supposed to work on it. Five times -4 does multiply to -20. 5 plus -4. Will that give you -1?
Well, hold on, hold on. Let me show you that.
Oh,
Yeah, I'm reading. Thank you.
That is correct now.
wait.
Hold on, I'll be right back. Nice. Show me both sides. And you get 2 pieces. Cool beans.
It's on chocolate.
There is non-chocolate. You got to kind of dig for it. Like there's a cherry Jolly Rancher. I think there's some Warheads in here somewhere. But there are non-chocolate options. Nicely done. Yes.
See, the one with the actual long division makes sense.
Good. The only time that you want to be really careful about using this is if when you find this first piece, if that's a fraction or a decimal, long division is your better choice. I can still show you if you want me to how to do it this way. You just have to like do an extra piece at the end. It's not horribly difficult, but I don't show it because too many steps and I start to lose people. Yes, sir.
This will be 20. That's supposed to be 21.
That's x plus 3, right? So,
That is a negative.
okay, that's, I couldn't tell if that was a decimal or a negative. Where's your box on the outside? I know there's some more heads in there because people in 4th period found them. Yep, I was gonna say, I knew there was warheads in there.
Oh, sure.
Everybody,
There's another one. I saw it. Wait.
There you go. You're welcome. Did you do the 3rd one? Did you do the 2nd one? You have a piece? You don't want it? Okay. Trent. Let's look. You brought a 1 down. What do you have here? So what goes here? Finish it out and call me over again, okay? All right. You got that one if you want to grab a piece, and then I can give you another piece once you got the other one done.
Okay, I'm done. I need to discuss with you about this.
Let him finish up his problem first.
About what? You doing the on the back?
Yeah, he's working on the one on the back.
Yeah, it's.
Okay. Righty. If you see this right here, that would go with that one. So that's going to change these two, just switch them around which one's negative. But other than that, that's absolutely perfect. Yep. So yeah, it's going to change those two there. Yep. Help yourself. 2 pieces. You good? Okay. Great.
It was right here.
Michael, it's not your record.
You're not coming. It's mine.
That's your name.
You're welcome.
It is, hey, Michael.
Yes.
It's Mike.
Okay, guys.
Mike heard.
It's not like
Mike
I'm
heard.
calling out here.
And then Mike heard.
Oh, dang.
Show me yours. That should not be a -3 down there.
Where'd you get -3 from?
Cause the -3 and 1.
Oh.
No, you drop the 1 down here, the -3 goes there. But other than that, yes, I just don't want you to get confused by your own results when you're doing it on the test.
Because you don't know how to do it. I'm not even your mom.
The homework that I've put up on the board the last 2 days, that's due on Monday. If you got all of those problems done, you're done.
Hershey's good.
Hershey's is good. It's just like chocolate.
Yeah.
Chocolate.
So there's like, this is dark chocolate, and then this is regular chocolate.
There we go.
You're welcome. Yeah, that's the gold on the edges, and then it'll usually have a red banner on it. I love dark chocolate. Love it. Be careful here. Here you had a +4, so that would be a +4.
Oh.
So that'll be positive, which means that'll be negative. But other than that, your work looks great. Would you like candy? Okay. All right, coming around to the other side of the room. Did you do number 2 or number 3 with us? You got number 2. You want to grab a piece? You guys have number 2 or number 3 done? Nope. Jaden, you want 2 pieces?
Yeah.
All right.
Let me get this one and
You know that's dark chocolate, right? There's regular chocolate in here too. So the way you know the silver ones, that's regular. The ones that are gold, and then they have a red banner on them are the dark chocolates.
I'll take this one and this
All right. You're welcome. All right. Very nicely done, ma'am. You want candy? You're welcome. You want 2? Can somebody grab the door, please? Yes. You might need to go to the software center, so like the O drive. I haven't. I was getting ready to on this break, honestly. Okay. 2 pieces? Oh.
What about the 4?
Let me check your answers to that, but you can at least grab 2 pieces. You're welcome. Did you get it? Yes, you dropped your 1. What's -3 times 1? That should be a -3 right there.
Yeah, what?
This times this, answer goes there.
Oh,
Then you add them. And then it's this times whatever you got after adding those. And then that answer goes there. Okay? All right. Stanley, did you want 2 pieces? Okay. All right. Nice work today, guys. Hey, by the way, please do not get rid of these pages. We will be using them again. All right. If you went ahead and finished it out, don't worry, you will get rewarded for that in time. But please do not get rid of these pages. Also, as a reminder about your homework, as soon as my board catches up, awaiting connection. Come on now. Hold up, guys. Bell hasn't rung yet. There we go. Homework up on my screen. Same exact assignment from the last 2 days. It's due on Monday. So if you had been working on it and you got done with those problems, there's no reason why you should need to do anything over the weekend. All right. I'll put this right back up in a second. I'm just going to end our Zoom first.